today we will understand about voltage divider rule. So in voltage divider rule, so there is a resistance R1 and this is the midpoint. This is resistor R2 and this is connected to ground. So this resistor is R2, this resistor is R1. Here is a Vs, source voltage. So we want voltage here, V output. What is the V output here? If two resistors are R1 R2 are connected like this, this is battery positive Vs, this is the ground. So the V output is equal to Vs multiplied by R2 divided by R1 plus R2. So this is called voltage divider rule. So this is the formula you have to remember. V output is equal to Vs multiplied by R2, R1 plus R2. This is the voltage here we can calculate by this formula. So now there is a case 1. If there is a case 1 is when R1 is very big resistor than R2. If R1 is a very big resistor, so in the denominator R1 is a very big resistor, R1 plus R2, the whole denominator is very big value, and R2 is very small. So in this case, V output is approximately equal to 0 volt. Very less voltage you will get if R1 is very big resistor. And now there is case 2 when R1 is equal to R2. When R1 is equal to R2, in this case VO is equal to Vs by 2, because if we put R1 here, R1, so there are two R1 will cancel out, so Vs by 2, half voltage. Like if R1 is 1 kilo ohm, R2 is 1 kilo ohm and Vs is 5 volt, so you will get a 2.5 volt. And the next case is case 3. So in the case 3, if R2 is very big resistor with comparison to R1, if R2 is very big resistor, then VO is equal to, so in this case R2 is very big resistor, so R1 is very small, so R1 plus R2 is cancelled out by R2 because it's approximately nearly same value. So VO is approximately equal to Vs. It means if you increase the value of R2, VO is increasing. If you decrease the value of R2 like this, then VO is decreasing. So this is called the voltage divider rule. So this is the photoresistor, or this is the also called the LDR, that are light dependent resistance, or it is also called the photoresistor. It is called a photoresistor. So in this, when you put light over this, when you put light, so if you, this is Li means light intensity, so if you increase the light intensity over there, so the resistance is decreases, and if you decrease the light intensity over the LDR, the resistance is increasing. So this is the LDR. The value of resistance depend on the light intensity. If you put more light over it, the resistance is decreasing. If we put it into in dark area the resistance is increases. It means light intensity is decreasing, resistance is increasing. So this is the LDR. So now this is the voltage divider rule. So now the first case, if R1 is replaced by LDR, if R1 is replaced by LDR, so in this case we are replacing R1 by LDR. So this is the LDR symbol, and this is the again this is the R2 normal resistor. Here is the LDR, and this is the VS, and here the we required VO. So in this case, now if you are increasing the light intensity, Li means light intensity. If you are increasing the light intensity on R1, this is at the place of R1. So now R1 is increasing or decreasing. So in this case R1 is decreasing. So when R1 is decreasing, because when you put the light, the resistance value is decreasing. So whenever you increase the light intensity, R1 is decreasing, because the resistance of LDR depend on onto the light intensity. So now R1 is decreasing, it means V output. Now R1 is decreasing, so it means V output is increasing. Similarly, if you decrease the light intensity, it means the R1 is increasing. If R1 is increasing, the denominator value is becoming a very big value. So now V output is decreasing. So it means if you put this complete circuit onto the light area where there is a light intensity, so V output is increasing. It means if there is a LEDs, if you connect any LEDs here like that, at the here, if you connect a resistor with series LED like this is the LED. So this LED will glow into the light, and when you put this circuit into a dark area, so R1 is increasing, V output decreasing, so LED will not get the sufficient voltage to glow, so LED will not glow. So LED, when LEDs glow, when you put this circuit into the lights, so that's why it is called light sensor. So this is called light sensor. When R1 is replaced by LDR, so this circuit is light sensor. The LED is glowing into light when there is a more light intensity. So this is light sensor. Now the second case, when R2 is replaced by LDR. The R2 is replaced by LDR. So in this case, this is the R1, and this is the R2. So R2 is replaced by LDR, and this is the R1, and this is the VS, and here is V output. So whenever now, if you increase the light intensity, R2 is decreasing. When R2 is decreasing, it means V output is increasing or decreasing. V output is decreasing. So Whenever light intensity is decreasing, it means R2 is increasing. If R2 is increasing, it means V output is increasing. So whenever, if you connect here the LED with series resistor, if you connect here the LED will glow into the dark area when VO is increasing, when light intensity is decreasing. So it is called a dark sensor. The earlier one is the light sensor and this is the dark sensor. It is sensing the dark. So in IBM Cloud we are using the first one, light sensor. In our IBM Cloud we are using the light sensor.